Welcome to What's New in Electronics Live 2018. We're at the NEC in Birmingham. Now I'm joined by Naim, Kapadia, Joe Booth and Michael Ford to talk about smart factory evolution. Though I think we need to qualify that, don't we? Where are we at with a smart factory, and what is a smart factory? It's probably something different to various people. So you, Naim, are doing a lot with the NTC of trying these things out. You know, you it's a test bed for all the things that are coming on. The talk you just gave was incredible. The breadth of research and development you're doing in all these different areas. So what does it mean to you, a smart factory?
So I believe that the vision I've got at the moment is around the co-robot, as we call it, the collaborative robot, the factory of the future, where the flexibility needs to be there in terms of the machine. Machines could be placed in any corner, and you have robots to actually go to to do certain things. Now, there is with having this factory evolution, there's obviously going to be some reduction in terms of the low skill jobs, but the way the MTC have seen that there's going to be some development around other skills areas, and there's going to be more jobs. There's going to be low skill jobs going, but there's going to be some highly skilled or skilled jobs coming along that will make more jobs in the UK, which we're obviously looking to help. So, as I mentioned in my presentation, we've been investing quite heavily in the apprenticeship program. We've been taking 40 people a year. This year we've taken 100 apprentices, and next year we're going to take 200. And taking that sort of level of people, obviously there's around the engineering, and so we can take these people having the highly skilled in engineering jobs, and then they go back and into the industry and help the other engineering companies to make them, to take them to the next level, really.
That's fantastic. Joe, you were just saying actually about where a lot of people are thinking they're smart factory ready, but sometimes they aren't.
So from what we see, of course factories are already pretty smart, but we think that they could get a lot smarter. So typically a lot of companies are focused on SMT and really creating an environment around SMT that's quick, that's efficient, that gets you the most from your production. But I think we see a smart factory as a factory collecting lots of data and using that data for automatic and continuous improvement. So we'd suggest that you can be smart as a factory by powering profitability outside of just SMT. So looking at your goods looking all the way from supply chain to eventual final box build. And we think from us as a distributor, we see a lot of companies now broadening what they're looking at as a solution because of the fact that we have sensors in equipment. That equipment is now talking to each other with advancements like CFX, for example, and Hermes communication. Well, now the next step is really using the data points that we've collected through these production processes, understanding them properly with correct algorithms or statistics, and then coming up with a solution to drive increased profit margins, which is effectively what business leaders are looking for, at least what we found. I mean, there is also people looking to promote jobs, but at the end of the day, CEOs of these manufacturing companies are looking to drive profit, and that's one of the biggest drivers that we've seen from our market, at least.
Michael, what's your take on it?
I mean, first of all, let's put this into context. I agree with you that factories are already smart, but the smart until today has mainly been in the minds of people. We got some really smart people running our factories. Line managers, people doing capacity planning, people organizing things. You've got to hand this to the guys. They do a great job of running manufacturing. The problem is with these people is that they're human. So whenever a decision has to be made, like a customer comes along and says, I would like to make another 1,000 of these because I've got a rush order, can you sort it out? And it's people thinking, talking to each other, walking around, asking for opinions, checking the material supply, wondering what will fail if we do something different. And so that is the limitation of human beings. It really is. So no matter how smart you are, Unless you've got your fingertips on the information, you're powerless. So talking about CFX, Hermes, and the ability for machines to help with executing decisions, bringing the information to the people, and allowing them to have this holistic view of everything that would be affected, in a what-if scenario, I were able to do this. This is making help for making smart decisions. So it's people being augmented, if you like, to make these smart decisions. Now, will we get to a place where we would like to be smart in terms of reacting to customer needs or changing requirements without people being there? A lot of the decision making may be done in that way, and we will see factories evolve to become smarter and smarter by understanding the patterns of changing customer demand and what that means in terms of changes in the process. We need people, smart people, to have the right information to lead us down that path.
With that, actually, I think in terms of being like process smart, one of the things that we've seen is a big adjustment in how people perceive what's in the line. So of course you have SPI and AOI. Well, traditionally the AOI was like the policeman of the line. So reflow was like, AOI going to tell me that it's not placed right, or my screen printer is wrong, or my solder paste is wrong. People are now looking at AOI and SPI and thinking, actually you're not a policeman of the line. I can actually use the data that you collect to improve the process of the other steps. Right. So all the data points is important, the images, what's captured. If you study them correctly and there is a false call or a fault, you can look back at the data, see how you could optimize your print process, or see how you could optimize your reflow profile to mean that you actually create better outputs at the end. So I think we're also seeing a change in how people perceive this tool. Okay, it's not damaging to the others. I'm actually using that data to really improve. And it comes down to smart people as well. But getting the most out of the machines you have, really.
But what you're saying there is quite profound, because if I were a vendor of AOI machines, I mean, in the past, my sales pitch would have been, you know what, you need to find the defects before they get out of the factory or before they get to the next process, so I'm a defect finding machine. Well, that's kind of a negative sale, because I wasn't intending to make any defects. Yeah. So if I was good at production, I wouldn't need your machine. Yeah. So now, as a modern AOI machine vendor, I would say exactly as you're saying. We use the AOI to measure and get the data points of what's been produced. There's no defect. But what we're saying here is, using Six Sigma and other analytics techniques, we can take that data and predict any likelihood of future defects, and then avoid them. So my sales pitch as an AOI machine seller is not, this is something to find defects. This is a machine to prevent defects. And that's a real profound change, which you described there.
And the smarter the factory gets, you're hanging on how smart your delivery of parts, components, your delivery of your product to your customer, all those sort of things. It's no good having a smart factory if you've got dumb bits surrounding it. How far do you think the factories can go into that? And is there, is there a cooperation all through those other levels of running and making a business efficient?
So we have kind of like a real example, I suppose, because we do work in the goods in area as well. So one of the key points that we've seen without sort of pitching a product is around component counting. So people getting smart around supply chain. So now what is a reality is having a system that manages your stock from kitting in the store into production, and from production back to kitting. And if that system has MES capability in terms of connectivity, effectively what you could have is an automatic supply chain that your machine that's keeping stock has said, oh, you know what, we've got 5,000 of those components left. Let's have an automatic order placement on our supply chain to refill that stock. And then if you think about product planning for, say, the next month, jobs come in and you're aware of what your output needs to be in terms of components, or you can automate the retrieval of those components by knowing what your stock level is very closely. And that's the change from having like a constant audit to one monthly audit where everyone's sitting in the factory floor spinning reels, or you can have a compatible system that talks immediately. But again, the same driver is having data points, having connectivity, and having a reason to improve process, which is profit, I'd say, at the same point. Because if you have an unknown shortage, let's say you've lost 200,000 parts, what's the lead time to replace those parts? How long is that going to affect production? And this is where we say that people are looking outside of just SMT to think, you know what, there's other opportunities here, and people can sort of buy them because the justification is enough. Say your line's down for 1 week, that's typically enough for justification, at least that we've found.
Yeah, I mean, last time there was a material shortage in the market, there were cases of large manufacturing sites in Europe shutting down because they didn't have the materials to make the products. Wrong. They did have the materials. They just didn't know where they are. They'd got such a mismatch between the real inventory and what ERP thought. So this whole concept of lean materials, ordering the materials to the line when and where needed, is really important. And the accountability through MES of each individual component in the factory is critical. So that then you can come along and say, well, I am constrained with material. Could I execute this work order without any risk? And the answer is yes, I do it. And if the answer is no, you know it's no. It's not, I'm not sure, maybe we'd better not, just in case. So that's all about the control of materials, especially in this climate.
And the other part I'd say for this component into production story is effectively, and we've seen them, the little robots that drive around delivering component parts. So you've also got storage towers, and plenty of suppliers have the storage towers for lines, but you also have the big lifts. But the pick and place these days are actually talking to your storage towers, talking to the other parts, and soon there'll be a point where you're smart enough in your factory that your pick and place is low on this reel. Okay, you're going to auto load that reel, but the reel is going to be delivered to you on a robot next to the operator on the line, or in fact might be some point where a robot can do the auto change on the reel. So that's kind of the next step in component delivery, because you know that you've got about 1,000 left, where you know when that's going to run out and when you need it to you. And with these sort of robots moving things around production, it's definitely going to be possible to really reduce change over time. Again, I think.
So another thing I'd like to add to that with this smart configuration, it gives people, the public, more flexibility of what they want. What configuration they want, what color they want. And going down the smart route, they can select certain things. If you want to buy something now, you can configure to whatever you want, and before you know it, it's out there in the factory. So it'll give you that. The other element of it, one of the things we're looking at the moment, is what we call factory in the box. Again, we can only do that if that smart factory exists, and then look at it. If we can make it smaller, then we can put it, closer to the, to the people. So we've actually had a project. It was quite a large project, making some pipe work, but it was all done in a factory in the box. But the technology is that you can put it in the middle of a desert, and that's the whole concept. You don't need to be in a factory. But now what we're learning from this is we need to know and understand having it on site first, understand the technology, and then maybe moving forward, then start looking at, well, can we now take it to the next level by putting it into a box? Having imagine a 40-foot truck with everything in there in line, and then but it's all automated, putting the PCB in one side, and then you got the assembly on the other side, or maybe the end product, the whole thing, but under a factory in the box.
Well, that would revolutionize logistics, because now you have a truck leaving a factory with finished goods. You have the truck leaving the factory with raw materials, and when it arrives at the destination, the finished goods come out. Interesting.
Would the smart factory be smart enough to know that there's a component shortage, look at what you're producing via all the technology we've got, and say this component would do just about as good a job by just slight change in spec, to then talk to the customer, come back with a okay for it, and then carry on seamlessly?
Actually, this is a critical area right now, because when you design a PCB, the designer has in mind a particular material to use. Then the bill of materials is passed into production. They don't like it, because some of the components are a little bit difficult to get hold of, they're more expensive, so they go out to the market and, okay, what could we use instead? And sometimes it's, as you said, there are the need to change to an alternate value, an alternate supplier. That may bring in changes in the shape or the size of the component, which may not be suitable for use on the board. So there's a whole lot of decision making to be done continuously now, because even if you are producing a product and you notice one particular component is short, it can be the most insignificant part, like a dust particle of a resistor, but you don't have it, you can't ship.
Yeah.
So you've got to go out and find an alternative. But what are the consequences of choosing that alternative? And how do I communicate to my machines so that they automatically compensate for both placement, inspection, etc.? So that is a real smart process in itself. So having software that can do that is actually part of a missing link that we've had in manufacturing for quite some time.
Yes.
So we deal with the design, we deal with manufacturing, but we don't deal with the purchasing or procurement of materials to the level that we're going to have to for the smart factory of the future.
Yeah, and I'd say there's a lot of pressure globally on component shortages, right? So everyone's heard about instances where they don't have enough to meet production. So the area around that needs to be tighter. Because I don't think it's really acceptable to not produce because there's components not available, because you've just planned poorly at the end of the day, or you haven't planned far enough in advance, or you haven't looked for alternatives really. But with the capabilities in MES, and with the multiple suppliers and different PCB design ideas, and new component ways of making components effectively, and new methodologies, it should be a thing that we should be able to solve, or at least find ways around, I'd say.
Yeah.
True story. I heard a couple of months ago a new AI was developed for purchasing in an ERP environment. And with the potential material shortage on a particular component, this AI went through its algorithm and came up with the only possible solution. Buy a year's worth of inventory. So it basically brought mayhem to the industry because already these parts were in short supply. And if these AIs are just thinking without judging the consequence of their action, they just make the problem worse. And literally they're sitting on a warehouse full of endangered components because, it thought that's the best thing to do.
And we've heard of that actually in Eastern Europe, because we've got some companies out there that we work with. We've heard that companies are actually building warehouses to store components, 9 months worth of components sometimes, with big automotive, where they've got the money to buy them in advance. That's a possibility that they could just erect a building like this and store all the components in, right?
But then what happens later on when they find they've got a surplus? They sell them off on the grey market. That's the opportunity for counterfeit. All kinds of problems could happen as a result.
It like you say, in theory, it should avoid the need, the situation you ever have excess inventory or overstocking or buying components or buying extra components because you're concerned they may not all be up to scratch. It should be able to get rid of all that, but then you go the other way. It becomes it causes its own problems. Then if you've got the ability to create a factory in a box, you're almost creating factories for a particular solution, aren't you? You can if you can create them quick enough, they can go out and solve that. They can, and if it was mobile, you could go where the raw materials are, then to the point of delivery.
I think the issue with the factory in the box, or maybe that something that needs to be overcome, is the factory in the box needs to be flexible enough to be applied to multiple products, right? And whether that's like a high mix, high volume CPH pick and place, or whether that's really looking at how we integrate each step of the process. So there needs to be a way, whether it's assisted robots or whether it's clever board handling, or whether it's a way to really make sure that not just from a hardware perspective but from a software perspective these machines can sort of communicate freely, because if they don't have the flexibility, then a factory in a box is only going to be good for one product, and then you can't switch it to another, and then you'll need a new factory in a box for every single run that you make.
And then you're back to old school.
So I think integration is one of the big factors that people need to kind of focus on, and there are solutions, and I guess the CFX line is going to be a step forward, but we need to have all suppliers come into the table with their ideas and with the ability to communicate, or otherwise it will make the whole process kind of useless to a sense if people stand out and stay away from it.
Exactly.
What's your take on that, Naim?
So we're obviously looking at it from not just within the factory. We're opening it to from supplier all the way to to the end customer. Again, as I mentioned, the history, Industry 3.0 has always been around within the factory. Now collecting the data around the cloud and all the rest of it, then that data needs to be, as you mentioned, the algorithms and all the rest of it, so they can get some useful information out of it and do something with it. But it's all to do with flexibility, what the customer demands are. Everybody has a need of something, different colour, different. People have different perception of things. It's getting that onto the cloud as well as meeting the demands. What we want. If there was just two colour cars, for example, black and white, and that's all they're going to choose. But now, if they've got a variant colour, they will choose whatever colour's out there, and then that will allow to sort of pull a demand to manufacture something. So I think moving forward, one of the other things we're looking at the moment is how can we make, for example, feeders. Can we get robots to do the changeover?
Yes.
And that's the key, because it's the added value what the customer's paying for is the PCB or the assembly of the PCB. They're not paying for the reels to go on or the rest of it. So we're trying to look at the non-added value activities to see if we can automate it as much as we could, and that will help hopefully with the low volume, high mix manufacturers.
Yeah, and I'd say from the supplier perspective, all suppliers are moving away from having an off-the-shelf product, because nobody wants an off-the-shelf product anymore. All suppliers will say that the method that they want to sell is solution-based selling. So people don't necessarily care about some of the finer details. They want to know that this is going to be a solution to the wider problem. So I think that more suppliers can get more value out of the market if there's more collaboration. And that's, I think, where they're integrated, where it's not just a pick-and-place machine or an AOI. It's something that can do more and provide a full solution to the end customer, because that's really what they want. They don't want to have to buy Koyoung, Yamaha, Rem or whatever. They want to have a line that works optimally from what they want. So it's the whole package of those machines together that's the ideal solution.
Yeah. So smart factory is only as smart as the data we get and how smart the interpretation of that data is, isn't it?
Yeah.
And how much foresight you've got and how long you take it along the supply chains and delivery chains. They're the challenge, aren't they?
And there's some real drivers. I mean, what we see in the UK at least, and I don't know if it's different for different areas, but this has really been led from our side by automotive, because of the need to really work with small margins and get everything as optimized as possible. So at least from our customer pool, we'd say that they're kind of leading the way in terms of really optimizing how the process works, but that's purely because they're dealing with such a small amount of margin to do it with, and incredibly high numbers. So if you can optimize a process by a second for them over 5,000 PCBs a day, that's a serious, significant uplift, I think. So that's what we're seeing. And then if automotive buy in, then it's sort of trickling through the smaller manufacturers, and then suddenly you see small CEMs wanting to integrate a similar process because they've seen it on a customer visit or something like that.
But do you think that automotive with the electric cars, hybrids, is a little bit of a clean slate, isn't it? Because it's a new area that has created huge demand, huge innovation, and it's almost an exponential jump in what electronics companies can do, have to do.
It really is. I mean, if you have a look at the popular electric car providers like Tesla, for example, a very large part of the electronics in the car is there to protect the batteries. It's safety-related electronics. And okay, automotive is safety critical anyway, no matter what kind of car you have. But really, for electronics, the focus is really for these electric cars. But I think automotive are guilty of something which is, in manufacturing, it's always the end assembly line which is king in the factory. Whatever you do not stop that line. Now, automotive, when you buy a car, you've got an option list as long as your arm now. So the combination of different options that you create is huge. So what do the automotive vendors do? They make a very flexible production line, so you can make any product with any color in any order at any time. It sounds a great way of making cars, forget the fact that they're all being made at the same takt time, so somewhere somebody's losing something. But anyway, that final line never stops, same takt time, off it goes. But consider the people supplying that line. They aren't included necessarily in the idea of should the supplier of this subassembly, of this radio or whatever that thing will be, that option on that list, is that optimization geared for them? No, it's not. Now, typical in automotive, whenever you make a change in anything, it has to go through a very long proving procedure to make sure it's going to work right. But now these guys are being faced with having to change frequently because the automotive makers are pushing the flexibility back up the supply chain. So they're faced with a conundrum. Do we relax our testing and the stringency with which we approach the lines and how they're set up, or do we become more flexible? This is a decision that they have to make. And this is where the technologies that we've been talking about, the evolution of machines and software, really come into their own. So actually automotive is leading the industry in having to adapt to these kind of economic pressures.
Yeah. Exciting times once again. I'm going to go and find a smart cup of tea now. But thanks for talking, guys. It's been really interesting. It'll be interesting to see where we're in a year's time, 6 months' time even. It's change is speeding up all the time, isn't it? And it's exciting. So thank you very much.
Okay.
Thank you.
Okay.